All right, well, hopefully you did well on your test. Students in here did a fantastic job on their test. Joshua now has another perfect test on the back wall. And once again, Lana missed it by that much. So anyway, we will see, Scott, if you are able to finally make it on the wall on this, your last, unless you really bombed it, last math test of the school year as well. Now, I do recognize that none of you are taking the final exam. I get that. However, students in the future who may use these videos would be perhaps taking final exams. So we're going to review for their benefit. But also, the review we do isn't all about the exam. It's really all about next year, being ready for Algebra 1. So don't take your mindset of, okay, we're reviewing for an exam. Not entirely. We're really reviewing so for Algebra 1 comes around, you're ready to roll. Does that make sense? So take that mindset. This isn't exam review for you. For some students it is, but not for you. For you guys, it's, I want to be ready for Algebra 1. Turn your books, if you would, to page 565. We're going to begin a large section of final review. We're going to kind of skip around a little bit. We're not going to do every problem. We really, frankly, don't have time. It would take a very long time to do every one of these. However, if you're one of those just unique people that loves to work stuff, you can go through and rework all the problems that we skip. But we will be skipping around just a little bit over these last several lessons leading up to the final exam, which is in lesson 178. Let's start on page 565, and if you would, go ahead and do numbers 1 through 9 there at the bottom of the page. 1 through 9 at the bottom of page 565. Just some basic math review. Make sure we don't forget some of the basics, because in Algebra 1 next year, I'm going to assume you know this stuff, and it's a problem if you don't.
You expect us to still remember all this?
Yes, yes. You are expected to remember what you've learned. I don't expect you to learn something and then go forgetting it.
Oh.
You're not allowed to forget anything. You'll hear that line a lot over the next several years. Here's why I say that. Because when you take senior year, you'll take your ACT or SAT to get into college, they assume you haven't forgotten anything. So if you want to be successful on that test, and therefore successful in getting into a premier college, don't forget anything. It's supposed to be in your long-term memory. So things like percents, you won't use them very much in Algebra 1, Algebra 2, geometry, pre-calculus. But then you're going to see those on your ACT, SAT tests. You better remember it. You better have it done really well. I remembered everything. I tested 99th percentile. If you remember everything, you can test really, really well also. But if you don't care, and so you don't keep it in your mind, and you forget stuff, that's when you struggle and can't get into the college of your choice. So it's not that I forbid you to forget anything. I realize, no, realistically, it's possible you may forget some things. But for your sake, don't forget anything. And that's why we're reviewing. Again, you could think also long-term, some of this stuff you won't see in Algebra 1, but guess where you will see it? Senior year College Board testing. So make sure this tucks away and stays in your memory. And to be fair, the stuff we learned this year, much of it you learned last year and the year before and the year before, right? Especially the stuff at the beginning of the year. It's old news. You've been working percents for years. It should be in there really well. Just like I shouldn't have to review 9 times 12 for you to remember it's 108. It should be in your brain so well from years of learning it. You should be fine. So Lana's got a bit of an unfair advantage there, having been in the system for so long. She's least likely to forget stuff just because she's had it so often. And Glenn and Hayden, you've been here for years. You know, by the time you get through 8th grade, you'll remember this stuff. Right. Yes?
I won't be here tomorrow after lunch.
What?
Yes, I won't be able to be. I'm leaving to go
What?
to school.
Oh, bless your heart. I mean, Ralph. Is he on the other team or is he on your team? So you're happy he's gone. Okay. Which team are you on?
Kind of Maddie, Noah, Jaden, Noah.
Okay, Maddie's team. Okay.
Because I feel bad for them. Yeah, because now they only have 4 people.
But they beat you guys. You can't feel bad for
No, I
them.
feel bad for him. I may be coming. It depends, because I might have to take my adversity exam. And and if I felt fine after that, I might just stay. Cause it's not, it doesn't feel too good when you come out of college.
We done with 1 through 9 yet?
No.
I've been talking too much. Well, for sake of time, let's take a look at the answers you have done, and we'll just quickly talk through the ones you didn't get to. Number 1, what is the place of the underlined digit, Lana?
9,000s.
It's the thousandths place,
Oh,
and then the
yeah.
value is
9,000.
9 1,000ths,
Yeah.
right? 9 over 1,000. Number 2, round that off to the hundreds place, Joshua.
16,700.
Good, the 9 bumps the 5 up to a 6, excuse me, the 5 bumps the 6 up to a 7, excuse me. Yeah, 5 bumps the 6 up to a 7, I was looking in the wrong place there. Number 13, explain why 13 is a prime, excuse me, number 3. Why is 13 a prime number, Lana?
I bet because it can only be multiplied by 1 in itself.
It can
Oh,
be factored into
oh,
1 in itself,
factored,
right.
yeah.
The only factors are 1 in itself.
Yeah.
Number 4, how would we rewrite that set of values in order from least to greatest, Joshua?
1.4, 1.436, 1.44, 1.51.
Good, 1.4, 1.436, 1.44, and 1.51. Number 5, how would we prime factor 75 using exponents, Lana?
3 times 5 squared.
Good, 3 times 5 squared. Number 6, what's the greatest common factor of 15 and 45, Joshua?
I haven't done.
Lana?
15.
15. You would factor 15 into 3 times 5. You'd factor 45 into 3 times 3 times 5. Okay, so let's go ahead and put that up here for reference, because the next thing we'll need is the least common multiple. And so, again, greatest common factor, they both have a 3, they both have a 5. 3 times 5 or 15 is the greatest common factor. But least common multiple is not about what they have in common, it's all about a contest, Joshua. How would I find the least common multiple?
Like you see which one has the most threes, that would be 45. And then you see which one has the most fives, and they both have fives, so you just take one,
Which one?
45.
And so obviously the least common multiple is
45.
45. It is its own LCM. All right, number 7. Find the least common denominator of 7/27ths and 5/18ths. Now the hard part about this is we can't look at them and be like, oh, yeah, both of those, you know, if you times tables or whatever, you can't really use that here. But we could use a little prime factoring. How would we factor in 27, class?
9 times
3 times 9, and 18 could factor into
3, 2 times
2 times 9. So you notice they both have a 9, right? Or we could say this way, 3 times 3, if we were to break it down all the way to prime factors, right? The winner of the 3's, loser. The winner of the 2's. So what is the greatest common factor? Or what is the least common multiple or the least common denominator?
27? Wait, what?
27 times 2.
Which is?
$54.
54. There we go. So by prime factoring, we can get the 54. Obviously, here we were missing a 2, so we make it 14 54ths if we wanted to change to the LCD. Here it had the 2 and 2 of the 3's. We were just missing another 3, right? So that would give us 15 54ths. And with that common denominator, we can see that 5/18ths is a tiny bit bigger than 7/27ths. Just barely.
So you were just finding numbers?
All we were looking for was 54. That's the LCM. But I wanted to show the application of the LCM. It can be used to add fractions, it can be used to compare fractions, all those things. What would we divide out of numerator and denominator to reduce 45/60ths in one step? Anyone?
15, yeah.
15. Good. That would be the least common, that would be the greatest common factor that you would divide out. And how would we rewrite 2 to the negative 5th using positive exponents?
1 over 2 to the 5th.
1
Oh,
over
right.
2 to the 5th. Because remember, negative exponent means reciprocal. Good. Turn the page. And we're going to drop down to number 16. Which of those numbers are natural numbers? Which ones are natural numbers?
111.
Only 111. Not negative 18, because remember, natural numbers aren't negatives. And not 0, by the way. Which of these are integers?
111.
Negative 18.
Good. Negative 18 and 111, both, because remember, an integer is just something that doesn't have a weird fraction or decimal with it. Which ones of these are rational?
Negative 18.
Negative 18 is rational. It could be written as negative 18 over 1.
3.4.
111, because it could be 111 over 1.
And then 3.44.
3.44 would be 3 and 44 hundredths, or 3 and 11 25ths. And then the only one that's irrational here is
Pi.
pi. If they'd had the square root of 8, what would that be?
Irrational.
Irrational,
Oh,
right?
yeah.
Because it also is a decimal that never ends and never repeats. But if they had the square root of 16,
Rational.
that's rational, because that's just plain old 4. Looking at numbers 20 to 23. Go and do 20 to 23 real quick. Put those symbols in there. Less than, greater than, or equal to. All right, number 20, we would say that negative 14.6 is less than negative 2.1.
Wait, which way is that? Like this way?
The point aims at the negative 14.6 and the mouth opens to the negative 2.1.
Yeah.
Yeah.
All right, we would say that the absolute value of negative 76 is
Equal to.
equal to the absolute value of 76. In both cases, the absolute value is just 76. 1/2 is
Less than.
less than 3/4, because remember, a half is 2/4, and 2/4 is less than 3/4. And 0.144 is less than 0.2. All right, questions on those? Look at number 24. They want us to write a ratio here. Global Auto sold 84 SUVs and 21 sedans. Listen carefully. What's the ratio of SUVs to sedans?
$84 to $21.
84 to 21. But we can reduce it
Yeah,
down, can't we?
that's what I was trying-
Yeah, and Lana's working on reducing that now. Josh was reducing
Wait,
You couldn't reduce.
4? Well, a
4 to 1. 4 to 1. You could divide a 21 out of both of those.
Oh.
Yep, we didn't memorize our 21 times tables, but yeah, 4 to 1. And Lana's starting to say 4, just a refresher, ratios always have two values, antecedent and consequent, so 4 to 1. Number 25, 27 softcover books, 9 hardcover books. Now listen carefully. What's the ratio of softcover cookbooks to all cookbooks? Softcover to all cookbooks.
$3 to $4.
3 to 4, very good. 27 to 36, which reduces to 3 to 4. Number 26, you can probably solve this in your head. 3, right? Equal ratio method there, right? Multiply top and bottom by 3. What's the other way to solve a proportion like this?
cross multiply.
You could cross multiply, but here equal ratio method just works so well. Number 27?
99.
99. How about 28?
14.
14, divided by the 2. All right, let's skip over to the next page. Number 33 real quick. Let's look at that one. What do we call that thing, class?
Complex fraction.
Complex fraction. Really, a complex fraction is just a
Division.
division problem. That's what a fraction is, right? The fraction bar means division. So really, Lana, number 33 could be read
50 over 3 divided by 1/9.
right, 50 thirds divided by 1/9. But do we ever really divide fractions, class?
No.
No, we...
Multiply by the reciprocal.
So we would rewrite this now, Joshua, as...
50 over 3 times 9 over 1.
And we don't really want to multiply 50 times 9 and 3 times 1. We'd rather do some canceling, Lana.
Like the 3, 1, 9, 3.
Right, divide a 3 out of both of these. So remember, cancel a denominator with a numerator. And now when we multiply, we just get a whole number, class.
150.
150. Questions on complex fractions?
Mm.
Number 35, 36, and 37. You're rewriting as in decimals, rewriting as fractions, and rewriting as percents. Take a few minutes to work these 3 problems. This is a skill that you're not going to see a lot over the next few years, but you will see it on the ACT and SAT. And when you see percents, you need to be able to use them interchangeably with fractions, decimals. So really good exercise for sake of review. 35 through 37 on page 567. Take a few minutes on these. All right, let's see how we're doing on these. 3/5 as a decimal class. 0.6, that's memorized, isn't it? Or you could remember that decimals mean tenths, hundredths, thousandths, 10,000th, right? So you can either get a denominator of 10, 100, 1,000, or so. For this case, times 2, 6/10ths, 0.6. What about 9/25ths?
0.36.
0.36. Again, multiply top and bottom by 4 to make it 36 hundredths, 0.36. How about 125%?
0.7 repeating.
Oh, I'm sorry, I skipped one. I'm sorry, you're right. No, letter C is 7/9, that is
0.7 repeating.
0.7 repeating. We remember that anything denominator 9 is itself repeating, other than 9/9. That's not 0.9 repeating, it's 1. Let's see, 125% letter D,
1.25.
1.25, and the last one was 3/4%.
0.0075.
Good, it's 0.75%, and then move the decimal 2 more places, 0.0075. Number 36, you're changing each of these to a reduced fraction. So 0.15 becomes 3/20ths. It's 15 hundredths. Divide out the 5 to get 3/20ths. What about 25%?
1/4.
1/4, and that might be a memorized one, right? Or you could say 0.25, which we memorized as a fourth. And then what about 62.5%?
0.625.
It is 0.625, which remember those 3-digit ones are what denominator?
1,000.
Well, I mean, yeah, you could say 625
Oh,
thousandths.
eighths.
It's eighths. How many eighths is 0.625?
5/8?
It's 5/8. You got 0.625, 5/8. All right, 37, express each of the following as a percent. So letter A, class.
30%.
30%. Move the decimal twice to get a 3 and then a 0, 30%. What about letter B? Percent means what? Hundredths. What denominator do you want?
100. Oh, yeah.
So we get
18.
18%. There we go. And then what about 5/6?
83
Good, that's 0.83 repeating, which is 83.3 repeating percent, which is 83 1/3%. Great job, Lon, on that last one. All right, questions on decimals, fractions, percents. Again, that is something that in just real life, for one thing, and then periodically we'll see that come up in different things where decimal percents really going to save you a lot of time and trouble if you've got those memorized and are able to work interchangeably with those questions there. All right, I want you to do numbers 40, 41, and 45 now. 40, 41, and 45. Remember the is means, is means
Oh, wait, no.
equals,
Yeah.
of means
Multiply.
multiply, and percents have to be changed into decimals. All right, doing those 3 problems. That's the student who forgets their pre-algebra. Just kidding.
Oh,
I will say I've had a number of students, into their senior year, they take that ACT test, and they're like, a fourth of it was pre-algebra, and I forgot all of it. And I look at them and I say, what have I told you all these years? You're not allowed to forget anything.
I forgot how to
So much pre-algebra.
I forgot how to subtract at the beginning of the year.
That's a bummer.
Yeah, it's
it's hard to get back.
Yeah. or
Summer,
12 weeks?
like summer,
Well, we'll just do year-round school, and then you don't.
no.
I'm just kidding, just
No.
kidding. I do not like the idea of year-round school.
Yeah, cause you'd have to work all the time.
Well, I work year-round anyway, but yeah, not
I
a.
wouldn't get like any kind
Well, what they do for year-round schools is they do like 3-week breaks between each quarter.
Oh, sweet.
that's not too.
To equal up in the summer?
Right, so it ends up equaling the same amount of breaks. You're still only doing 180 school days. You just take bigger breaks periodically to break up the
all
year.
day long.
I don't like that though because some students need summer school. Hayden, I'm just kidding.
Not
Just
to go
kidding.
summer school.
But some students do though, right? Well, if you do year-round school, you can't take that opportunity to help students who need it. And that's why I'm very much against the idea of year-round school, so.
Yeah.
Now, don't worry, I'm not advocating for that. Do they do year-round school in Japan, Scott? I don't know. You'll have to let us know. Have mom
Yes.
email and let
If
us
they
know.
do, I feel bad for you.
Yeah.
Well, he's not in the Japanese school. He's still with us on the GCS
Oh, yeah,
Mobile.
yeah.
So it doesn't really matter what they're doing as far as he's concerned. But you know,
Well, if he ever had to.
yeah. All right, let's see how we did on 40, 41, and 45. Number 40. What is 1/5% of 150, Joshua? 0.3. Very good. Number 41. 6 is what percent of 40, Lana?
15%.
15%. And number 45. 90 is 150% of? Ooh, it's 50% of 80. It's 150% of 60. Real quick, let's look at that one. We would say that 90 is or equals 150% or 1.5 of or times what number? And then to solve for x, we'd have to divide away the 1.5. So we would say 90 divided by 1, well, not 0.5, right? We'd have to move that decimal over here. So it becomes 900 divided by 15. You end up getting 60 when you divide it out. Tell you what, let's do number 46 as well. Go and do 46 real quick, just to make sure we've got a good handle on this. not Scott. This is a geometry test. Ethan. He didn't already have one, so this would have been his first, right? Super close. Are we done? Well, let's take a look at numero 46. Josh, what'd you get for this one?
300.
Okay. So, we have what is it, Lana?
30.
30. 1.5 is, or?
Equal
5%. What do I make that?
0.005.
Well, okay, so in 5%, the decimal's right here after the 5, right? We moved the decimal how many places?
Oh. I
One.
thought it was once before the.
No, it wasn't before the 5, it was after the 5, right? Otherwise it'd be 0.5%, but we don't see 0.5, we just see 5. So it should have been 0.05 times x, where we divide away the 0.05 from both sides, and of course that means we have to move the decimal back those two places again, and here, to basically become 150 divided by 5 is 30. Third tries the charm, do 44. Third tries the charm, do 44. Oh, yes it is.
There's only 5 Cardinals cards.
Sorry. Which guys you got?
I got Michael Shaw,
Waka?
Walker, Jack Flattery,
Flaherty. He's really good.
Bud Norris, Harrison
Bader. He's a good outfielder. He's a terrible hitter.
and wait, aren't you a Cardinals?
I am a Cardinal fan.
And Harrison Bader.
Harrison Bader again. Yeah, 2 Harrison Baders. Yeah, he's fun to watch play center field because he's so fast. He tracked down just about anything, makes so many amazing catches. But he comes up to bat, he strikes out like every time. It's awful. All right, though he has had a few homers this year. You know, he's made some contact for a change. All right, Joshua. I'm going to get you my lectern. 10 is 20% of what number? 50, there we go, we got it, all right. Let's go down to the word problems now. And number 47, tire company. Advertised sale 25% off all tires. If the list price for a pair of tires was that's cheap, was $120, what's the discount? And then what's the sale price? At your seats.
Such a long time.
Ah, yes. But this is real life math, so we definitely don't want to forget this.
We used to do like it in 2 steps. I can't remember.
Well, let's just think logically about this. What does 25% off mean?
Like,
No, off. Off and of are totally different. What does off mean?
That means you have to pay 75% still.
Okay, that means you're paying 75%, meaning you subtract 25% from how much you would pay, right? We call subtracted money savings,
Yeah.
right? For instance, this was $30, but we're going to let you have it for 10. I just saved 20 bucks, right? Subtracted amounts are called savings. So 25%, let's think logically here as well. I don't like to think 0.25. You know what I like to think?
25.
1/4,
Oh.
right? Because I can do in my head a fourth of 120. Chop 120 into 4 parts. What's each part?
30?
30. So you know what we save? If it's 25% off, that means we save 30 bucks. We can do that in our head, can't we? Right? 25 or a fourth off, a fourth saved. So if it was 120, but we're going to save 30, what's the sale price? We're saving 30 bucks, so we only have to spend 90 bucks.
Yeah.
There you go. Yes, it's really easy, and it's very logical, right? Now, I will say, if they're advertised for 27% off, okay, 0.27 it is, and we would take 0.27 times the 120, and we get whatever that comes to, right? It'd be a little bit more than 30. But 25%, I can think 1/4 and do that easy, right? So I'm a big fan of that. How about the next one? A school's enrollment was 150 last year, and this year it's 165. It says find the percent of change and label it as increase or decrease. How do we find percent of change?
Change over original.
Yeah.
Change over original. So what was the change class?
15.
15, and what was the original?
150.
So we put change over original. We could reduce this down, couldn't we? to get what?
1 over 10?
1/10.
Oh,
What is that as a percent though?
1%?
Ooh,
What? 10%?
10%. A tenth is 10%,
Oh.
right? Because that is 0.1, which is 10%. And is this increase or decrease, obviously?
Increase.
Increase. It went up from 150 to 165. 10% increase. Right? So see, we remember this though, right? We're just trying to shake off. And there's a reason we're doing this at the end of the year, because if we shake off the rust now, that was from 8 months ago, but it's still there, right?
Wow.
It's there. We're just shaking off the rust. In 3 months, you'll still remember this, hopefully.
Yeah, 'cause
Yeah. All right, let's take a look at number 49. An ice cream container that used to hold 32 ounces. Oh, this is so true, y'all. Okay, so I just bought spray paint for field day, you know, the racing area for field day and all that. They used to come in 17-ounce cans. The price is the same, but it ain't a 17-ounce can of spray paint no more. It's 15 ounces.
wow.
I looked at it, I'm like, this feels a little smaller than usual. And I looked at it, I was like, 15 ounce. They're going to save money however they need to, right? You start inflating, they're not going to raise prices necessarily, they may shrink the packaging, right? They start selling Cokes that are little tiny 8-ounce cans. It used to be 12-ounce cans. And they say, look at this, single serving. But you know what they cost? The same thing the other ones used to cost. Anyway, all right, so anyway, 32-ounce container now has 5% less. How many ounces of ice cream can it hold now? 2 ways to solve.
Oh.
Your choice. That's 5% less ice cream than it used to have. So it's not 32 ounces anymore. Yeah, that'd be a 2-lub container. Because there's 16 ounces in a lub. So if it's a 32 ounce container, that's a 2-lub container. You knew there were 16 ounces in a lub, right? You had that this year. Yeah, so you know that. You're acting all confused and stuff. Silly Hayden. He's silly, isn't he, Glenn? So the 5%, 0.05, that's 1.6 ounces that it no longer has, right? It's 1.6 ounces less. So what do I need to do with the 1.6 ounces? Subtract from 34 to get, or subtract from 32, excuse me, to get 30.4.
I got 30.3.
Ooh, careful. 32 minus 1.6. Borrow.
9 minus 6 is 3.
It's not a 9. When you borrow the 1, it comes over as a 10, because this was 32.0. Yeah. Or, Joshua, I think you did it differently, didn't you? You said 5% less means it still has 95% of the ice cream in there, right? So you could also say, well, it used to have 32, and it still has 95% of the ice cream. And you can do it that way as well. And notice you still get 30.4 ounces. So a couple different ways you could work the problem. Questions on that? Did you get 30? Well, you just subtracted wrong.
No, I could have thought that way, but I was thinking something totally different.
Okay, the most conventional way, Josh, was just say 5%. Find 5%, and then since it's less means subtract 1.6 from the original 32. A couple ways we could do that one. Let's move on though. Page 568. What?
That ice cream number.
Now she's hungry for ice cream. We lost her. All right, we're going to drop down to the bottom of page 568 and do number 69 to 71, practicing order of operations. Now, this is very applicable next year. So this is very important for the more immediate future. We're not thinking, senior year testing for this. 69, 70, and 71. We just happen to still have this order of operations poster up. All right, let's see how you did on these. First of all, no parentheses, no exponents, but there's a multiplication and a division. So we'll do the multiplication, we can also do the division, and then we will add and subtract at the end to get 26. Are we good to go on the first one? On the next one, there is a parentheses. We're going to make this a 4, which you notice is up against the 5, which means we multiply. Also has a multiplication with the 2. But remember, we multiply left to right here. Also has an exponent, which we can simplify. 4 cubed to get 64. And then we're multiplying. Now notice this is a negative 5. Or you can think of it as a minus, and then just multiply 5 times 4 times 2. 40. So either 64 negative 40 or 64 minus 40. Either way you get 24. Good to go? Question, Josh? All right, looking at the next one, there is an exponent we need to take care of first. And remember, it's not a negative 3 being squared. It's negative 3 squared. 3 squared is 9, but it's still negative. So 36 negative 9 positive 21 all over 6. Remember, addition, subtraction. You don't add before you subtract. You just go left to right. 36 minus 9 is 27, plus 21 is 48 divided by 6. Now that fraction bar, remember, groups everything in a sense. We now can divide and get 8 for our answer. Questions on order of operations? Very quickly, number 72, the associative property. Do you remember what that means?
You multiply 8 times 4 next?
Right, it basically means you can put different things in parentheses. So instead of putting the 2 and 8 together in parentheses, you could put the 8 and 4. So you could write that 2 times 8 times 4. In a series of addition and multiplication, it doesn't matter where you put the parentheses, it don't change nothing. That's the associative property of both addition and multiplication. What about 73, the commutative property?
Backwards.
So in other words, 25 plus 75. Just rearrange the order of the terms because addition and multiplication are commutative. And then the distributive property means we would distribute to get what?
10 times 4 plus 10 times 9.
Good, 10 times 4 plus 10 times 9, or you could say 40 plus 90. You'd multiply the 10 by each of those values individually. Questions on that? All right, we will stop there for today. Real quick. I'm not giving you written homework, but tomorrow is going to be a frustrating lesson for you if you don't brush up on some things, because it's been a while. Write these pages down if you would. Write these pages down just to look over, no written homework, just skim the page, literally just speed read the page and refresh some things in your memory. And if you're like, ooh, I forgot that. Well, okay, maybe make a little bit more of a mental note then. Look over pages 60, 61, and 74. 60, 61, and 74. These are your units of measurement. And then also write down these pages 81, 82, 87, 88. 81, 82, 87, 88. These are going to be a little bit more important because you know most of your units of measurement from years and years of being at Grace. But scientific notation is a little bit newer. Those last 4 pages are some scientific notation review. That's also something we're going to be reviewing tomorrow. But the review will be most productive if you've looked it over and just kind of refreshed your own memory before we do the review tomorrow. All right, we'll see you tomorrow. Have a wonderful rest of your day.
Basically.